Good afternoon. I am Diego. I am one of the two Conan co-founders, and today I'm going to talk about Conan. First, what is Conan? Conan is a free and open source package manager, MIT license. It is universal. It can target any operating system and it can integrate with any build system. It is very efficient. It can manage binaries for managing huge projects, and it is stable, very actively developed, and very supported by both the maintainers, the company, and the community. What I'm going to talk today is about the graph model in 2.0. But I'm going to start first with how C and C++ binaries are built into artifacts. Then I will talk about how Conan 1x represents the dependencies in the package manager, the limitations of this model, and how Conan 2 can improve over these limitations. I will finish with a demonstration and conclusions. So first, let's start with this simple example. We want to build a small video game, and the game application depends on an engine library. And this engine library, in turn, depends on a math library that contains typical math operations. And both engine and math are static libraries by default, and game is an executable. So the interesting thing here is when I build something in the math static library, something like the add function that is adding two integers, then I will be getting an assembly that looks like this. By the way, this is Visual Studio in debug mode. But here we can see the add operation and the symbols. And then when we build the engine CPP that contains a move 3D function that calls twice the add function, then I will get an engine static library, which assembly looks like this. We can see that there are two calls to the add function, which is basically a pointer. This is not resolved in the engine static library. This will be resolved later when we call the linker. But the add function is not inside the engine static library. Then when we build the game executable, linking against these two static libraries, we will get something like this. We get this assembly for the game executable. We see the main function here that is calling move3D from the engine static library. And in the assembly of the executable, we will see a call that is a jump basically to other place of the assembly. And in turn, the move3D assembly code will be doing two calls to the add function that is also in that assembly. Because the linker, it took two copies, the copies of the static libraries assembly code, and it put it into the game executable. Of course, if we build in the release mode, this will be optimized and it will be in line everything, but the concept is still the same. We are getting copies of the assembly code of the static libraries into our executable. But if now we decide that the engine library we want to build as a shared library, then we will get something like this. The math static library will still be the same assembly, nothing changes. But when we are building the engine shared library, a DLL in this case, we will get an assembly that looks like this. Again, debug mode, non-optimized, but the concept is still the same. We see that the assembly in engine DLL contains a call to the add function, and it also contains a copy of the add function itself in the assembly of the shared library. And now the game executable that is built against this engine DLL shared library now is something like this. It contains a call, but this call is just a pointer. It doesn't exist in the assembly anymore, because that will be resolved at runtime. Only when the shared library is loaded by the system, this pointer will be actually pointing to the assembly code in the shared library space. But again, the important thing is it doesn't contain a copy. It's very important to know because everyone is so excited, and so am I. This is great. Models are going to be great, but it's a build system thing. It's not a package management thing. It's not an artifact thing. Executables, shared libraries, static libraries will still be the same. And exactly the same thing that we are seeing, like assembly code from an artifact that is being embedded in another native artifact, it still happens with models. It's exactly the same. By the way, if someone wants to learn more about models, I like this talk from Daniel Anger. So I suggest having a look. Okay, let's see how this affects package management. And in this case, we will start describing the Conan 1 model and how it manages the packages and the binaries. First, this is the basics. We have the math library, and for creating a package of the math library, we have a Conan5.py. It's what we call a recipe. A recipe is a Python script that contains the description how these package artifacts are built from sources. Okay, so is this in a simplified way? This is the recipe that contains a source method, how to get the sources, the build method, how to build from sources, and the package method, how to actually extract the artifacts and create the final package. Okay, so when with this package recipe, we can do something like this. We can clone the math repository, and we can issue a Conan create command. This Conan create command will take the Conan file recipe, and it will start executing the methods, and we will end with a math library, a math binary for this source code. When we want to represent a dependency in Conan, this is what we have. In our small example of the game, we have the math Conan file. It's exactly what we have seen. I've removed the methods for simplicity, but the methods would be there. And the engine the same. It will contain also methods for building from source. I've removed them. The important bit here is the requires. To represent a dependency from engine to math, we have a class attribute that is called requires that will point to the package and the version of the package that we want to use. Or if we need some conditional logic, we need something more powerful, we can use the same in the requirements method, and we can apply some ifs there if we want to conditionally depend on the math library. But the idea is the same. We declare a requires from engine to math. So when someone clones the engine library repository and it contains the Conan file and they issue a Conan install command, what happens is Conan will go and check the Conan file from engine. It will find the requires to math and then say, okay, I need math 1.0. It will go to the Conan cache. It will go to the servers, fetch that math 1.0 package, and it will find there the Conan file for the math package. It will check again. Okay, no requires. Stop. This is my dependency graph. And once it has the dependency graph, it can prepare the thing to build the engine package. In this case, as the engine package is declaring a generator to CMake depths, it's basically telling, hey, engine is built with CMake. Please, Conan, generate for me some CMake files so I can use them in my build. And what Conan will do is, okay, you depend on math, so I will create for you a math config.cmake file that contains a math target that you can use in your build. This is a bit simplified, but that's the concept of how Conan works. So when the developer that is working on the engine source code, they can start running CMake, calling the CMake list of engine, and it will find the math config CMake, and it will find the math target. It will be able to link with the math library, and everything will work. Exactly the same process is done when we have transitive dependencies. In this case, if the developer is going to be building from source the game executable, it will be cloning the game repo. It will be issue a Conan install, and it will proceed in the same manner. It will go to the game Conan file, find a requires to engine. Okay, I need to fetch the engine package. It will look for engine 1.0 inside the Conan cache or in the server, fetch it, find a requires to math. Then it will fetch the math package. It will find no more requirements there. It will stop. This will be the dependency graph with these three packages. And now Conan will generate two files. It will generate a CMake file for engine with a engine target, and it will generate also a CMake file for math. So game can now link with engine and the math static libraries because it needs them for being linked. Okay, this was a bit simplified model. Let's see now how Conan manages the binaries. So when we're talking about a package like the math package, we are actually talking about this. We have seen the recipe, this Conan file script that describes how these binaries are built. But every time we call a Conan create, we create a package, then a binary is produced. Okay, and we can have as many as these binaries as we want. Every time we build with a different configuration, we are going to get a different binary. Those binaries are identified by what we call the package ID. The package ID is basically a hash. It's the SHA-1 checksum of this. Okay, this is the configuration. A bit simplified, but the idea is there. If we take the settings, some things like the operating system or the architecture, the compiler version, build type, okay, and we change any of those things, we are going to get a different binary. Our assembly code will be different. Okay, for example, if we change from x86-64 architecture to ARM-v7 architecture, we are going to get a different binary. That's obvious. And also, there is another thing with what we call the options, that is something per package. That is, for example, a package can be a static library or a set library. And in some situations can be one or the other. If we change that, the math static library is going to be obviously a different binary than the math shared library. So if we change the option shared from false to true, we are going to get a different configuration. This configuration is going to be hashed into a different package ID that represents the unique binary that this configuration produces. This was a bit simplified view of the configuration that is put into the package ID computation, because as we have seen in the first part of the presentation today, also the dependencies also matter. So if we are building a binary here for math, and let's say that math depends on setlib and boost, and if we are building a binary against setlib 128 and boost 168, we are most likely going to get a different binary for math than if we build from setlib 1 to 11 and boost 175. Okay. So what the package computation, the package ID computation does, it also takes into account the versions of the dependencies that I'm using to produce my binary. Okay, let's finalize describing the Conan 1 model, talking about tool requires. So something that very early in the process, when we were releasing Conan, users asked for, hey, can I put, you're talking about libraries only, right, and executables. Can I put a tool itself into a Conan package and then use it for building my other packages? Like the canonical example is CMake. Can I put CMake, a modern version of CMake, into a Conan package and then use it to build my other packages? And then we created the concept of build requires or tool requires. Is basically the name. Tool requires is the modern naming of build requires. They are declared exactly the same as a class attribute, as we can see here in the engine recipe. Tool requires equals something, and that will be a tool require. Okay, in this case, the CMake one in blue. The first important thing that we have to know in Conan 1 is that dependency graph for tool requires changes. It's not always the same. And it changes depending if you need to build from sources or you don't. In this case, if you are installing the game package, for example, and it is able to find a precompiled binary for engine, it doesn't need to build engine from source. And as it doesn't need to build engine from source, then the tool required for engine doesn't exist at all in the graph. So we have what we have in the left side here, that's the full dependency graph. CMake doesn't exist at all in this instance of the dependency graph. But if in other situation, we are building engine from source because maybe it doesn't exist, that precompiled binary or something, and we are somehow engine is being built from source, then the tool requires is used. And in this case, the dependency graph will contain the CMake tool requires of engine. So engine can be built from source. It will require that CMake version here applied to engine. A very interesting thing that tool requires introduced in Conan 1 is the concept of the context. This is very evident in a cross-building context. Let's say that now our little game, we want to target a Raspberry Pi. We want it to run in a Raspberry Pi. But we are cross-building. We are building this thing with our cross-compiler in Windows. So the thing is that our packages, the game, engine, and math, should be built from the Raspberry Pi. And the configuration that we should be used is the operating system is Linux, and the architecture is ARM-v7, and so on. This is what we call the host context. That's the naming that GNU is using, and that refers to the machine where the software will run, in this case, the Raspberry Pi. But we are cross-building, and that means that the CMake that we are using cannot be the CMake built for Linux. It has to be a CMake for Windows 64 bits. And that means the configuration for the build context in blue is a different one than the one that we are using for the host context. So basically, tool requires always live in the build context that is the current build machine that you are using. That can be different from the host context. This was very evident for cross-building, but it happens the same in other cases. A very typical one is this one. You want to build your game in debug mode because you want to debug it, right? So your configuration will contain build type equal debug. But that doesn't mean that you want CMake using a CMake that was built in debug mode, because it might be very slow or it can have tons of traces that you don't want. You still want the release executable of CMake. That means that the configuration context for the build context will be build type equal release. So even in this case that we are not cross-building, tool requires live in the build context, which is different from the host context. Okay, so let's talk a bit about limitations of the Conan 1x model. And before that, I want to say, introduce a number of figures, metrics about the project. For example, the ISO C++ survey of the last year is showing that Conan as the most user language-specific package manager. And we also have some data about for example, the community. In this case, this is the number of pull requests that Conan repos in GitHub are getting per year. You can see here in the last year, 2021, we got more than 4,000 pull requests from the community in our different repos. This is the number of visits. This is our web traffic. Most of this, and we see that it's in the millions and thousands of unique users. Most of it, like I'm talking 80% to 90%, is in our documentation. Okay, which is great. It's not, they're not reading our marketing blog post or whatever. They are reading our documentation. And another good metric, this is the telemetry data we have for the Artifactory servers, JFrog Artifactory servers. That means that there are at least out there 8,000 teams, companies running Conan in production. Okay, every team, each one of these servers can serve teams from a few developers to hundreds of developers. Typically they range from startups, and we know that many of these companies are Fortune 100 companies. We know they are using us. Why am I saying this? I want to highlight that this is not something that we are inventing. This is not something that we want. This is the result of thousands of support tickets, thousands of conversations to customers saying, hey, team, we need this. This is important for us. You need to improve this. This is limiting for us. This is painful, whatever. So this is what I'm presenting here. And this is the reason Conan 2 is going to evolve in this direction, because we have been listening to all this much feedback. So let's start with the limitations. First, about the transitive headers feasibility. So this is our small example. Here we can see a standard thing. We have our CMake list, we have our game Conan file.py with a request to engine, and we have the game CPP source code. Okay, so this works in Conan 1. Okay, it's fine. You do the Conan install, you get your files, you can build the thing and everything. It works. Okay, but then one day, some user came to us and said, hey, but one of my developers added this include math.h in game, and it compiled. And we say, hey, great, it worked, right? Say, no. It really needs to fail. This is a bad thing. This shouldn't be possible at all. And we say, oh, wow. Yeah, let's stop for what is happening here. Okay, yes, the Conan install is creating the engine CMake and the math CMake files for us. Both of them locate the engine libraries and engine headers and the math libraries and math headers. So the math headers are by default exposed to game. Okay, and there is little that we can do because actually we have not enough information in Conan 1 to deal with that. But we were thinking about this is a toy example. Of course, in these three packages graph, it's not a big deal. But many of our users they are having graphs of many dozens. I'm talking 150 packages, dependency graph there. And when they have up to hundreds of developers working on the same dependency graph and in the same project, this is a problem because engine can evolve. And the team that is developing engine might decide to drop math dependency or to upgrade it or whatever. And game only depends on engine. Okay? And then suddenly something game is not compiling anymore. It is, hey, but why? Game only depends on engine. Engine, the API of engine is still great. It didn't change the API of engine at all. Why is game breaking? And the answer is because some developer introduced this indirect dependency via this include. Okay, and we want it to be catch very early in the process, so it's not a problem later when something changes in the dependency graph. We say yes, you are totally right. The default for headers is that they shouldn't be propagated downstream, and packages should explicitly define what they require in order to use those headers in the default case. Something very similar happens to the libraries and the linkage requirements. So far we have been seeing, and we have been talking static libraries. But what happens if engine has an option, a shared equal true or false? It can be a static library or a shared library. And now suddenly, someone is doing Conan install engine shared equal true. Okay, and now we have this thing that happened in the assembly code that we are seeing. The math assembly is being linked into the engine DLL. And now game shouldn't receive anymore the linkage of math at all. But the problem is, okay, our files don't know that. They don't model that at all. So the math config and the engine config CMake files, they are still propagating the linkage requirements to game. Again, in most cases, it doesn't matter. The linkers are smart. They can strip away all the symbols that are not used. So if game doesn't have is not using any functions directly from math, it's not going to be a problem. The math assembly will not be copied into game. But yeah, that's simple, works. But if you have a 150 packages dependency graph, maybe your link time is minutes, many minutes. Okay, just because it's doing a lot of job and you want it to be efficient. Or you have a complicated link step, and sometimes it will really embed a copy of math into game because, yeah, bad luck. And then your game size starts to grow. It won't break, but it's just annoying to see the size of your assembly executable to grow without a reason. And then, yes, game shouldn't be linking directly with math because it has already been embedded into the engine executable DLL. Okay, about conflicts and dependencies visibility. This is the typical diamond structure that we can have in dependency graphs. In this case, we have an artificial intelligence package that also depends on math. It defines its requires to math 1.0, besides the engine package that already depended on math. And if game now depends on both the artificial intelligence package and the engine package, we will have this diamond structure. Okay, so far, this is good, this works. But this also opens the door to the possibility that we have a conflict. Because if, for example, the engine team decides to use a modern version of math and they start to use math 2.0, then we have this dependency graph. And this dependency graph means that game is going to try to link against two different binaries of math. And then you get the duplicated symbols error all the way. It's basically not possible to have this. Conan 1 is fine. It will detect this version conflict and it will tell you, hey, you have a conflict, solve it. It is also interesting to know that this conflict also happens, and this is particular for native builds. It doesn't happen in Python, for example, or in Java. But in native builds, it happens when your binary can be different. Let's say that the math package has a configuration, an option that allows you to define the accuracy of the mathematics there. And it can be either double or float. And then the artificial intelligence package decides that float accuracy is good enough, and then they define it in their options. And then the engine, they need double accuracy, and then they are defining default options. So even if now exactly the same version of math is used, then the binary is still different. and we have two different binaries, and if game is going to try to link with these two different math libraries, you will get exactly the same link errors, the same duplicated symbols errors, and it basically won't link. So Conan 1 so far did this right. It is able to detect the conflicts, and it's able to allow users to resolve them. The problem comes when this has to be allowed. And yeah, this happens. So some teams came to us and say, hey, but we have this. We have the artificial intelligence package. It has millions of lines of code that depends on Math 1. This is not going to be upgraded anytime soon. And we also have the engine team that decided to upgrade to Math 2.0. Okay, we know it's not ideal, but I guarantee you that nothing is propagated via the APIs. So artificial intelligence and engine are both set libraries. Okay, I know it, I control them, I build them, they are set libraries. Anything from math is propagated via the public API of AI and engine packages. Nothing. Nothing is propagated. It's also very important. API is very evident that it's not propagated. You can check the headers, public headers, analyze the includes, and you can be sure. But also, I know I've done a lot of testing and whatever. I know that nothing escapes the ABI of the packages. No object is constructed in memory and passed along from engine to AR or whatever. I know that, and I know data is also visible, propagated via the public interfaces of these packages. So I know I'm fine. This should work. This should be allowed to work. Again, this is not great. We always prefer everything to be upgraded and everything, but this is real life. And one of our premises in Conan is we want to support the real use cases of the users. So this should be possible. Conan 1 was kind of possible, but really challenging to get this right. Oh, this one. We were so naive when we decided to model the package ID, how we compute the package ID regarding the versions of your dependencies. And this is what we decided. Okay, Sember is almost a standard, right? It should be right for us as well. Why we wouldn't? Well, okay, so we decided Sember. And this means that if we have the engine package that contains a version range that allows math between 1 and 2, because we know math package version is API compatible, we can write this. We can have these two dependency graphs in two different points in time. First, it resolves to math 1.0. And then some time later in time, then they release the math 1.3 version. And then our dependency graph for game contains math 1.3. So this is what we are baking into the configuration file for taking into account the dependencies. It's the Sember representation of the dependency. And the Sember representation means major doesn't break. So we say, okay, so the mapping of math 1.0 to a Sember compatible representation is math 1.y.set. And math 1.3, exactly the same, is 1.y.set. That means that exactly the same binary for engine should be able to be binary compatible with math 1 and math 1.3. And that might be okay, or it might not. It depends. Specifically in the binary embedding case, it is not right. And also, it's okay, but it's fine. You can bump the major. Okay, if you bump the major, in this case, we resolve to math 1 on the left and to math 2 on the right, you get two different Sember representations in the configuration. You get math 1.y.set on the left and math 2.y.set. And those result in two different package IDs and two different binaries. Now we have a binary for engine that is binary compatible with math 1 dot whatever versions, and we have another binary for engine that is binary compatible with all math 2.0 versions. Okay. Really bad things. Project in C++, specifically open source projects, but also company projects, they don't use Sember this way. They use basically the major version for C++. We use it as a generation thing. It basically never changed in years. It's like Boost. Boost is 1 dot something forever, right? And we use the minor as the major. And we do breaking changes. We remove things. We change the APIs in the minor. Okay, so just expecting projects to bump the major for this to make sense, simply doesn't work. Okay, and finally, the last limitation that I'm going to talk is that tool requires cannot be factored into the package ID computation. So even if I know that using different versions of CMake will affect my binary, I cannot do this. I cannot ask Conan to the, hey, if you're using this CMake version, then I want a different binary, because maybe CMake introduces some compiler flags here. Okay, this is not possible, and I'm going to explain why. I'm going to explain how Conan is actually computing the binaries that are to be used. The first stage in the dependency graph resolution is computing the graph of the host context. So we resolve the game that depends on engine, that depends on math in the host context. Then we take the configuration, we take the settings, the options, and the versions of the dependencies, and we feed them into the graph, and we compute the package IDs for every package in the graph. Then we check if these package IDs are found in somewhere. Yeah, do we have a precompiled binary for this package ID in the cache or in the remote? We are able to find in this example math and game binaries, precompiled binaries. Okay, everything good. But for some reason, the engine binary is not there. Then only in that case, Conan decides to expand the dependency graph and add a new node to the graph, expanding the tool requires. That basically means that this is a chicken and egg problem. For knowing when we want to expand the dependency graph to add the tool requires, we first had to compute the package ID. And then that means that all the tool requires cannot be part of the package ID. Okay, so let's see how Conan 2 is going to improve overall all of these problems. I wanted to also briefly introduce this because I'm really excited about Conan 2.0. Conan 2.0 is going to be a huge release, and it is improving many things in Conan. Conan 1 is, to be honest, is already 5 years old. We have been doing a great job trying to maintain compatibility in all this time for all the Conan 1 series. But there is already too many legacy, too many bad defaults, too many things that have changed in time. So now Conan 2 is going to change all those things. We are going to have a new user commands layer that you can customize. We are going to have a public Python API, something that our users are really looking forward. We have a new binary compatibility system, new build system integrations, many things. The log files, for example, and the CI is going to improve a lot as well. So many things are going to change. Today, I only have time to talk about the dependency graph, but I'm so excited about what is coming with Conan 2.0. So this is the new killer proposal, the new amazing proposal of Conan 2.0 is this, is we will handle the requires with a self-requires map 1.0. This is the major advance in the graph mode. Of course, the truth is there is a lot more there, but as we are going to propose also a smooth syntax compatibility to move forward from Conan 1 to Conan 2.0, we also have to be very careful with being able to write this common syntax between the two versions. So this was important. This really looks like exactly the same, but it is not the same. The major difference here is now that the requires, they have to introduce a concept that we call requirement traits. And a regular requires, self-requires math 1.0 by default, it contains many traits. I'm going to start with the headers and the libs traits. The default requires assumes you are requiring a library, okay? And by default, when you are requiring a library directly, you will use the headers of that library and you will use the libraries of that library. Okay, so by default, header trait is true and lib trait is true. And now we have the information. When we are creating the CMake files to build engine, we can use this. And we say, okay, you depend on the headers, fine. I'm going to add include directories property to the math target. So engine will find the headers in math. And you are using the libs of math, fine. I will add an interface link libraries property to the math target so engine can link with the libraries in math. If for some reason we write explicitly in the recipe headers equal false, then the CMake file that is being generated for us will completely omit the include directories property of the math target. So the math headers will not be available while building engine. It's not something that you typically want to do. If you are, of course, linking with using math, you will want the headers, but this is how Conan handles this trait, these header traits while you are building engine. And exactly the same, if the libs trait is false, now the CMake file that is generated doesn't include the link libraries. So it will only provide you the headers of math, but it will not provide you the link libraries of the math libraries. Okay. And then the very interesting thing is how the transitive requirements are propagated. So we define two different types of requirements, of course. First, the direct explicit requirements are those that are defined in recipes. So we have the game that contains a direct explicit requires to engine, and we have engine that defines explicit requires to math. Okay, those are direct requires and represented here. But the thing is, in the dependency graph, this is creating like kind of a virtual computed requires, and it's telling a game, as engine depends on math, game also depends on math somehow. We need to understand how, but game depends on math. This is a transitive requires is equivalent if we wrote self.requires math 1 in the game recipe, that we don't, but it's more or less the idea. Okay. So let's now, the key point of the new 2.0 model is this, how the traits are propagated in the graph from upstream to downstream. So I told you by default requires define true and headers and libs equal true. Okay. And the question here is, okay, if the explicit requires define this, what are the traits? How game is going to depend on math? And what are the values of the headers trait and the libs trait that are defined in this virtual transitive requires from game to math? This is basically a function. This is something, the inputs that we have for this function is the explicit requires and their traits from game to engine and engine to math, and also engine and math packages themselves. They have other information there we will see later that is useful. So we take these four things, the two packages information and the two requires information, and with that, we can define this F function that will tell us, hey, the trait that you need to use here downstream is this. In this case, we know it. We learn from our users. We know that by default, if we have these input traits and we have these input packages, we want the headers traits to be false. And we want the library traits to be true, because game still needs to link with the math static library. Okay, so that means, hey, I told you, when we are using this information when we are generating the files. In this case, we are generating the math config CMake file for building game. As the header trait from the transitive requirements from game to math is false, then we are not longer generating the input directories for math. And now we can build game, and game will not have in this include paths, it will not have the math headers at all, because the headers equal false trait remove it. Okay, they say, okay, this is great, this is looking great, right? Until someone tells you, hey, but I have this. I have in my engine package, I have some classes there that uses matrix, and I have a include directive here that is using things from math. That means you cannot remove the headers from math in game. They should be visible because the preprocessor is going to need them there. Okay, then with this, you have just broken this. Say, okay, yeah, don't worry. Now we have this traits framework to define how requirements work. So we introduce explicitly transitive headers trait. And we now have a mechanism to tell a engine, if engine, the engine package creator knows that he's using the math headers in the public API, and those math headers are visible, will be necessary in the include paths in game, it can define, me engine, I requires math, I requires the headers, I require the libraries myself, but also my consumers are going to require the headers because they are visible over my APIs. Then if we get this trait over the F function, then it will result in a transitive requires from game to math that now contains the headers trait equal true. And the opposite, if in other scenario and some developer there say, okay, engine, I'm a shared library, I'm always bit a shared library. I know that the static library that I'm linking math doesn't need to be propagated down to the game. So I can specify in my requires, I can specify a trait, transitive libs equal false. Okay, and that is taken by the F function and is propagating down to the consumer. So headers, it will be equal false. That was our default. That keeps being the right one. And now libs is false true. That means in this scenario, game doesn't need the math headers at all, and it doesn't need the math libraries at all, because it has in the middle this engine shared library that is completely decoupling the thing. And it will happen. It will basically, those traits will result in a math config that is empty. It doesn't define the libraries or the headers from game to math. Okay. And actually, as once the information is there, it can be even smarter. It can say, okay, that's perfect. I don't need the headers of math. I don't need the libraries of math. Why fetching the math binary at all? I can now build game application, and it will only need the binary of engine. It does no longer need the math static library in my computer at all. And this can result in huge time savings, because if you have 150 packages dependency graph, and you are building an application that depends on just 3 shared libraries, to build that application, doing a Conan install, whatever, will fetch you just 3 binary packages out of the 150. And that is really saving you a lot of time in CI and also in your developer's machine and developers' time. More traits. Now, we are loving these traits. They are really powerful, and yes, they allow us more. One of the things that Conan 1 didn't manage at all was the runtime. It didn't have information. Everything was build time. It was only considering what you do with libraries at build time. But some of these libraries might be needed at runtime when you are building your application. This functionality was improved adding the runtime trait. In this case, if we know, for example, that math is always a shared library, and we know it, engine knows that, or math, a very common use case, even if math is a static library, but that package contains some XML files, something that is going to be loaded at runtime. It happens, I don't know, in computer vision, pattern recognition, many things that depends on a file there. You actually need the math package to be installed in your machine at runtime to get those files from the package. That information can be provided with the run trait. And this is just another trait that it doesn't affect the build at all. So the math config.cmake is not affected by run. It's still driven by the headers and libs traits. But if you start defining run equal true trait, then Conan 2 will start generating files for you, like this Conan run.shell or bad, depends on your system, which contains variables that you can activate, and it will put things in the path. So for example, if math is a shared library and Conan knows that because someone defined run equal true, it will generate for you a script that you can activate, and it will contain the path to all the shared libraries. So everything works without copying around the shared libraries from one place to another, or without having to manage yourself. This run trait is by default propagated. If someone engine defines math is going to be needed at runtime, then game is going to need math at runtime. It doesn't depend how game depends on engine. The mapping is very, very direct. Someone requires something at runtime, downstream, you are going to need that at runtime as well. Okay, things start to get a bit complicated, right? I've explained a few traits so far. Headers, libs, run, transitive headers, and transitive libs. And now I have my requirements that I can start assigning values. If I know it's a static library, I will do this. If I know it's a shared library, maybe I want to do this other thing. If my headers are visible, I want to define those, right? So it seems that my recipes can get complicated very quickly. Because the truth is, when we are dealing with different types of libraries, my traits will be different. If something depends on an application, then you want headers is going to be false. You are not going to use the headers of an application. Libraries will be false as well, but run will be true because you want to use that at runtime. Okay? But if you are depending on a shared library, then your headers will be true. You still want to link with the library. Your libraries will be true. You want to link them. And also you need that artifacts at runtime. So it will have the 3 traits to true. And if it is static, it will be the same, but run will be equal false because you no longer need a static library at runtime. And similar with a header library. So now we have this, we have our requires, and we need to start defining different value for the traits if we are changing the different types of library that we are managing. And this is where we welcome another addition to the model in Conan 2.0 is the package type. Okay. The package type is just a class attribute that we can define in our recipes. So we can add in math package type equal static library, and we can also add in engine if we want package type equal static library. Okay, something like that. The truth is that it's not even necessary always, because we have other model in Conan like the options, and shared option in this case has become a standard, a de facto standard. Every package out there is using shared option. So if some package is defining the shared option, the package type can be automatically reduced. If shared equal true, it will be a shared library. If shared equal false, will be a static library. Also, header-only option is common out there for libraries that can be built in both header-only mode and compiled mode. So if we detect that the header-only option is there and header-only option is true, of course, then the package type will be a header library. So basically the values that package type can take at this moment are these: application, shared library, static library, header library. Library is like kind of an abstract one. It is telling, hey, I want you to really force that an option shared will be defined. Otherwise, I will error. Okay, and then I will deduce, based on the option, I will deduce if it's a shared library or a static library. But I want to make sure that Conan knows that that option should be defined, that should be used to deduce the package type. Then we can have build scripts to model just a package that contains some CMake stuff, for example, and Python requires. So now, how can we use this to define the traits? So basically something like that. In practice, this is the typical use case, how the package type helps. So for many cases, for example, if math is a shared library or a static library, I only need the options to be defined. And the requires has to be like this. Sorry about this. Yeah, requires is as simple as this, because all the correct traits from these requires will be obtained, will be automatically deduced from the package type of math. Okay, and only if I want to change something, of course, I always have the power. I can go to the requires, add the trait value that I want, and that will be respected. But otherwise, defining the options is good enough. And only in those cases that Conan doesn't have enough information, then it's good to define explicitly the package type. For example, for an application, it's not that easy to know that something is an application for Conan. Or, for example, if a package is always a shared library, always, but it doesn't contain the option because you cannot opt into shared library or static library, then you can explicitly help Conan telling, hey, package type equals shared library. But only in those cases, you need to specify that. And once that is defined, then in most cases, the requires doesn't need to explicitly define all the traits values. Okay, good. Let's continue with a couple of more traits. Now the build trait. Okay, we learned before in Conan 1 about tool requires, and now I'm going to explain the build trait. So basically, the tool require in Conan 2.0 is defined with the build equal true trait. Okay, adding that in a requires build equal true means this requires lives in the build context. Okay, this is the meaning of the build trait. This is build context. It will get the configuration from the build context. Okay, and being in the build context, typically by default, will also get a run equal true. This is typically a tool required. It's something you want to run. It's an executable that you want to run in your build. And as such, it will not generate any CMake file for you. That's ridiculous. Actually, it's a package containing CMake, so it doesn't make sense. But it will put this trait, run equal true and build equal true, will put the path of CMake into a script that is called Conan build.shell or BAT, depending on the system. I told earlier, we have now the two things. We have the Conan run for runtime, and we have the Conan build scripts for build time. So this is something that will be activated only when we are building. But when we are running the final application, CMake doesn't need to be in the path at all. So that's a different script. And the combination of traits, run and build, run equal false and build equal true, might make sense in other cases. For example, let's say that we want to put a bunch of build scripts, utilities, maybe data, some image files that we have there, that we only need them at build time because they are going to be embedded in my binary, for example. Okay, so then we don't need them on runtime because we know that they are going to be used at build time. And that means run equal false and then build equal true. In that case, that combination of traits, Conan doesn't generate any file. It doesn't know exactly what to do this because this is very specific to your build. And in this case, the engine package can get the access to my script artifacts and files via dependencies my scripts package folder. And if you are getting there the assets like images, you copy them, you build them, then you have the path, and you do whatever you want in your build to use those scripts or those assets. And now the other problem that we were seeing is fixed, because now this is the dependency graph that we get in the phase 1 of the graph evaluation. Okay, if you recall that, because basically tool requires and requires are not a different thing anymore. They are exactly the same. Tool requires is just an alias, is just some defaults, is identical to defining a self.requires clause with headers false, library false, run true, build true, and other things. So the thing is, when you are expanding the dependency graph, you always get the full graph, including the host context and the build context. It's not an issue. You get the graph of the recipes. It's not doesn't have an impact on time. Okay, but you always have the full dependency graph, always, of all the recipes that are involved in building something. It both host context and build context. And now, if you have the whole dependency graph before computing the package IDs for every package, you can factor the build requires into your package ID. And this is now possible with 2.0. Basically, you can use the same rules and put CMake Sember representation of the CMake version into the configuration that is going to be hashed into the package ID. Okay, and finally, the visible trait. The visible trait is basically removing what we have learned so far. By default, visible is true. That means that a game has a virtual transitive requirements to math, always. Even if it removes, even if this has headers equal false, libraries equal false, even if it's not using the artifacts, game still contains transitive requires to math. But this is the mechanism that forces the complete removal of the transitive requires. If we will put visible equal false, That means nobody below me, nobody below engine will even know. They will not see that math package is there. Is introducing a full break in the dependency graph. So now the transitive requirements from game to math doesn't exist anymore. And of course, engine is fully responsible to know what they're doing and know that they are shared library, embedding, whatever, but at least this is possible. So in our version conflict that we had before, and we had this situation, okay, now it is possible to handle that. Let's see, because the actual origin of the conflict, of course, is this. In the previous case, when visibility is propagated, we have a transitive requires from game to math 1 over the artificial intelligence left branch of the graph. And we have a transitive requires from game to math 2.0 that is created by the engine package in the middle. And now we have these two requires of math that goes to the game executable. And in this point is where the conflict happens. Okay, so basically, if we remove this transitive, we make these transitive headers to disappear, then problem is gone. The conflict doesn't exist anymore. And this is basically what is achieved with the visible trait. If both AI and engine packages, they know that nothing will conflict downstream, they manage the embedding of the binaries, they can declare the visible equal false trait, and then the graph will not conflict anymore. Looking good on time. Of course, that doesn't mean that in most situations we want to resolve the conflict. It's a good thing to resolve the conflict. It's a good thing that both AI and engine use the same upstream version. And we actually close the diamond. This might remove many runtime issues and everything. So if we want to force this into our dependency graph, now we have two other traits that we can use for this. The first one is the override equal true. That means override equal true means game doesn't directly depend on math. It will not introduce a direct dependency between game and math. What it's telling the override is telling, if someone upstream depends on math, I want them to depend on math 2.0. Okay, so this is basically forcing, in this case, the AI package that depends on math 1.0 is forcing AI package to depend on math 2.0 instead, and closing the graph. Of course, that this might create compilation problems in the artificial intelligence package, but that's another issue. Developers should go there, improve the API, but at least from the Conan point of view, you can create the graph that you want. This is the graph that you want, and you can define it, specifying the override equal true. And we have a different trait for when you have explicit, you have a direct game, for some reason directly depends on math, it declares, oh, something wrong there. So no, it's fine. This means game explicitly declares directly on math. But it still say, hey, I depend on math 2.0, and if some of my dependencies, in this case AI, is depending on math, I want them to be forced into 2.0 as well. Okay, because the thing here is that Conan 2.0 is more strict. It will throw more conflicts your way if there are actual version conflicts. Conan 1 was doing overriding in most situations that you wouldn't expect, because it was not explicit, but it was still overriding. Now it will always conflict, and you need to explicitly force or override if you want the dependency graph to be the way that you want. And finally, the new package ID. This is the feature that is going to save a ton of CO2 emissions out there. I really hope so. So we saw that the Conan 1 package ID mode is getting the Sember representation, engine depends on math 1.3.2, and this is mapping as math 1.y.set. Okay. The Conan 2 trait model introduced a package ID trait that allows you to explicitly change that. So engine can explicitly opt in to depend on math in patch mode. Patch mode means, everything down to the patch will be put in the configuration file, and that will be factored into the package ID. Okay, this is good. Conan 1 has something similar. This is not a really killer feature. The really killer feature is this, is that we have changed the default package ID computation. So even if recipes, they don't need to change anything in their package ID, this will happen. Okay. First, there are two modes. There are two major modes. The first one is the non-embedding mode, okay, which is the case that happens when an application depends on a shared library, or a shared library depends on another shared library, or a static library depends on another static library. The assembly code will not be embedded in the consumer assembly code. Okay. In this case, we are going to a minor mode. That means that if engine depends on math 132, by default, we are going to put in the assembly representation, we are going to put 1.3.set. That means that by default, every time the minor is bumped, you will need a different binary of engine. But if only the patch of math is bumped, you will not need a new binary of engine. That allows, if your developers know what they're doing, they can do patches to math, and this will not require rebuilding engine downstream, or other dependencies in the graph, of course. And this can save a lot of time. If your team is disciplined and they are really managing versions correctly, patch releases of a package of a static library will not rebuild the whole world. Okay. And the other mode is the embed mode. For all the other cases, for example, an application linking a static library or a header library, or a shared library linking a static library or a header library, or a static library linking a header library, by default, this is an embedding mode. The assembly of the dependency will be copied into the assembly of the consumer. Okay. In this case, we have gone full mode. That means, you take the whole reference of the binary dependency, which is the version 132 full, the revision, which is an automatic version that Conan is adding, which is the hash of the contents. You change a comma in your source code, and even if you are not bumping the version, Conan will compute a new revision for you. So that means that changing something in the source code of math, okay, will result in a new binary of engine, which is exactly what you want. Something changed in math, you need to rebuild engine, because the binary will always be different. Okay, and even the package ID of math is factored into the equation. Why? Because in the case we have the math package with float accuracy and double accuracy. Okay, if you change that changes the package ID of math, you also need to rebuild. You need a different binary of the downstream consumer application. So absolutely everything of the binary of the dependency is factored into the downstream consumer. And of course, one of the things that we are trying to be very careful with Conan 2 is being flexible. If you want to change any of these defaults, now you have full control. You can individually change the embed mode, the non-embed mode, the Python mode. You have full control over these modes that you can use. Okay, we are good on time. I will run a very quick demo. Let's try it. Here, is the font good enough? Okay, so let's go to the game. First thing I'm going to do is I'm going to run Conan graph info just to show you the dependency graph format. By the way, this is Conan 2.0 Alpha 6, which is already released. Okay, you can go there and you can start trying yourself. So I'm going to write the HTML format into my graph HTML. And I'm going to show you this graph HTML. And you will see that this is basically the example that we have been seeing today. Okay, we have the game application that depends on engine, that in turn depend on artificial intelligence and graphics. Well, it's a bit different, but it's more or less the same idea. That in turn depend on Mathlib. Here I'm using Mathlib because when I play the demo, math.h is a different thing, and I was getting system conflict, so I renamed it to Mathlib to avoid this. So this is my dependency graph. I can create my game package with this syntax, for example, version 1.0, and it will be basically fetching my dependencies. Here we can see that we depend on Mathlib. Okay, this is the dependency to Mathlib. when my CMake code will be, sorry about this, 1 second. Okay, my CMake will be telling, hey, it created the mathlib target for us. So it's actually getting the target from the math transitive dependency, and it is executing the game, which is printing one message for every library there. In this case, it is executing this code. It is written in the math library. Okay, and it's been actually being called twice because it's been called twice by the diamond dependencies. So I'm actually using the math library in my game, right? And I know this is a very small step, but I'm really excited about this. Now I can go to my game source code here. I can introduce the mathlib.h that actually exists there. And if I do a Conan create again, then my mechanism, that the traits propagation, doesn't make the headers from math available to game at all. And this is what developers get. They can no longer introduce hidden header inclusion in the game from math if they don't explicitly define a requires from game to math. Okay. So let's remove it. Let's make sure that this works. And the other thing that I'm going to demo now is also a very, very simple thing, but is the thing that I'm really very excited. Here I created my game package, right? So I can now, let's install it. Let's install requires equal game 1.0. And actually the thing that I'm most excited about is this one. You see here the requirements, artificial intelligence, skip. I no longer need this binary in my computer to install game. Engine package skip. Graphics package skip. Mathlib package skip. So when I'm installing game, in this case, I only need to fetch the game executable binary. And I will not even download all the other packages from the servers if they are not needed at all. Okay. This is the thing that will result in saving tons of time for things. Not only this, but this will also be applied for building. So Conan 2.0 will be building way less things if you use versioning correctly, while not skipping changes. If something changes that needs to be rebuilt, it will guarantee that things get rebuilt. Cool. We are on time. Perfect. About to finish. Okay, let's jump to the conclusions. So Conan 2 has defined a very powerful mechanism. Its base is built on three things. First, the requirement traits. We have seen a bunch of them: headers library, transitivity, visibility, build, run, and so on. There are others, by the way. There is the test one that I haven't talked about it. There is the options. For the first time, you can explicitly tell, hey, this package here has these options. Okay. That wasn't possible in Conan 1. 2, cope with the complexity that could arise from only the required traits. The package types solve the 90-something% of the cases that will not add extra complexity to your recipes. Your requires will still be plain requires, and just managing the package types, knowing that something is a static library or a set library or something, really brings the power, the knowledge of what Conan should be doing in order to do the right things. And the mechanism of how these requirement traits are propagated from upstream to downstream, taking into account the package types, is the proposal here. And with this proposal, we can do amazing things. We have seen and demoed that we can hide the headers visibility. We can really avoid the linkage, propagating the linkage through shared libraries if not needed. We can implement private dependencies, very simple. We can do things like bootstrapping. Now we can have a CMake 320 package to require CMake 319, for example, if we want to. Okay, the much better package ID will be saving tons of time of developers and CI. The tool requirements and executables is managed in a better way. conflicts and resolution is also necessary, and the smart skipping of dependencies. But the real power of all of this is that for most cases, nothing changes for developers. So we have something that in many cases it will look like this, just very simple standard Conan recipes with options defined. In most of the cases, when it is not necessary, it will use the package type explicitly, just one attribute to help Conan to identify what is the package type. And it will be this simple in most situations, but for really weird things that happens out there, and I can tell you they happen with C and C++ building, they happen out there, you will be able to implement them. You will be able to handle them because now the controls that you have over the dependency graph with the traits is much, much bigger. Okay, so I wanted to end today saying thank you first for being there, and some pointers. If you want more information about anything, the first entry point is Conan.io. Of course, that's very simple. You can go from everywhere from there to the documentation. There is already 2.0 beta documentation out there. Okay, alpha. You just need to go to the docs and go to the versions and click on the 2.0 alpha. Actually, we have a training for Conan 1. Okay, it's good. If you don't know anything about Conan, it's good. Go there for training. It's a free training, video format, self-paced. It's good to get to know about Conan 1. We will duplicate that for Conan 2 once Conan 2 is GA. If you have any questions, the best resource is GitHub. You can submit a GitHub issue for a question. It doesn't need to be a bug report. So please, if you have any question, any issue, any problem, open a GitHub and follow us in social. By the way, I wanted to say what I've been showing today is Conan 2.0 alpha. Okay, the plan is the following. We plan to go 2.0 alpha 7 the next month. That will be the last alpha, and then we will move to beta. We plan to do at least 4 betas is the expected thing, and then we'll move to GA. But beta is being there very, very, very close. I will be later in Gathertown. So if for the online people, if you want to try to reach me, I try to be there. If not, you can ping me. You can reach me in Twitter, Diego Losada. I'm open. You have any question, not only today, other day, and you want to talk this about and discuss anything about what we have been seeing today, please ping me, and I'd love to connect with you and talk to you and everything. And now I guess time for some questions. Thank you.